Hello students, this is a review of some real-world quadratic problems for the Common Core Algebra 1 Regents. This was a request by a student, so thank you. Whoever you are, you know who you are. We're going to be talking about rockets, squares, rectangles, and grappling hooks. The first problem, a model rocket is launched vertically from a platform 64 feet above the ground. The rocket reaches a certain height during its flight, and this is the equation for that height. S is the height of the rocket, T is the time in seconds. It asks when the rocket reaches its highest point, and we know that from our class, the rocket's highest point, that is its vertex. And specifically, it asks when does the rocket reach its highest point. So we're not just looking for the vertex, we're looking for the x value of the vertex. So when talks about time, that's the s variable, and the highest point is the vertex. You recall from class that the equation to find the vertex is x equals negative b over 2a. So here's that equation. And when we substitute in our b and a values, we get this. It should be negative 48 equals 2 times negative 16. We can simplify that to give us negative 48 divided by negative 32, and we can further simplify that to simply say x is equal to 1.5. So x is equal to 1.5. So that's the answer to this question. So we can state when does the rocket reach its highest point. We know t, or in this case x, is the time in seconds. So we can say the rocket reaches its highest point at t equals 1.5. And if you said x equals 1.5, you would be perfectly fine with that. Section B says when is its maximum altitude. We know that maximum altitude is also related to the vertex, so maximum altitude, we could also refer to that as the vertex, but it's not the x value anymore. The maximum altitude is the vertex's y value. And keep in mind that the x value is going to be talking about time, when. The y value is going to be talking about height, altitude. So in order to figure out the maximum altitude, in order to find the y value of the vertex, we take the x value we just found and substitute it into the quadratic equation. So if this were my test paper, I would first write down the exact equation, and then I would start filling that equation in with the t value that we just found. So we know that is 1.5. So that should be equal to negative 16 times, not t squared, but 1.5 squared, plus 48, not t, but 48 times 1.5, plus 64. And then we plug that whole mess into the calculator, and we will get our final answer. So I'll put my calculator here, and I've already typed that in. I substituted in 1.5 for all the t values, and I get 100. So S 1.5 is equal to 100. In order to get the full points, we're going to write it out as a sentence. We can say that the maximum altitude reached is 100, and if we look back at the problem, it talks about the measurements being in feet, so 100 feet. So one of the big takeaways here is identifying the different keywords and seeing what those keywords mean for the problem. Let's take a look at the second problem here. You and a friend are hiking in the mountains. You want to climb to a ledge that's 20 feet above you. The height of the grappling hook you throw is given by this function. How high will the grappling hook reach? Will it reach high enough to hit the ledge? So again, we're going to look at the keyword that says how high. And we know that in this case, we're talking about how high, that's the altitude. The highest point, that's the vertex. And we're not talking about the time, we're not talking about the x value, we're talking about the height. So we're going to be using the y value. So the first thing we're going to do is take the quadratic equation and identify the vertex and look for its y value. So we're first going to find the x value. X equals negative b over 2a. You know that's going to be equal to negative b, which is negative 32, divided by 2 times negative 16. It should look just like this. Now, if you're wondering why this negative 16 comes up in real-world problems all the time, the negative 16 refers to the pull of gravity. With any projectile problem, negative 16 is going to be the acceleration downwards due to gravity. And, it's the same for this problem. We have negative 16. Same for this problem. We have negative 16. So it just keeps popping up because gravity is a constant. Anyway, so what we can do now is try to solve this fraction that we have here. And it's actually fairly straightforward because negative 32 divided by negative 32 should just be equal to 1. So keep in mind we haven't found the answer yet. All we've found so far is the x value. So we have the x value of the vertex. The vertex has an x value of 1. Didn't have to write that, I'm just putting that for the video. How high will the grappling hook reach? Well, we know that this is our x value, so what we'll do is we'll take our equation, our quadratic equation, substitute in x1, and we'll figure out the height. So here we wrote down the quadratic equation, and now we're going to substitute in the value of 1. Now I'll write out the whole equation, and then I'll take out the t's one by one and replace them with the t value that we found. So you see the substitution process pretty clearly. Next, all we have to do is evaluate, and this one's a little bit more straightforward than the previous one because 1 squared is a little bit easier to calculate. So we know negative 16 times 1 is negative 16, 32 times 1 is 32, and negative 16, right? And then 5 is not altered. So in this case, we know negative 16 plus 32 is positive 16, plus 5 is equal to positive 21. The question says, how high will the grappling hook reach? Will it reach high enough to hit the ledge? And we know that the ledge is 20 feet above us. If it's 20 feet above us, and the maximum height is going to be 21, we can feel pretty confident that, yes, the grappling hook will reach the ledge. And, hey, here's some mathematical reasoning for you. 21 is greater than 20. When your grader sees that on the paper, they'll be like, wow, this student is really smart. Next and last problem. A square and a rectangle have the same area. The length of the rectangle is 5 inches more than twice the length of the side of the square. The width of the rectangle is 6 inches less than the side of the square. Find the length of the side of the square. So it doesn't look like a quadratic problem to begin with, but once we start setting it up, you might see some similarities between this and the quadratic problems that we've seen before. Okay, first I'm going to draw the square that they're talking about. Here's my square. Oh, that's kind of boring. No color there, huh? So we'll make a square. That's a rectangle. Not cooperating today. Oh, here we go. There's your square. And I'm going to use blue for my rectangle. If I can find blue here. Little Metro colors, go Knights. The square and the rectangle have the same area, so we'll have to suspend our disbelief here because it doesn't really look like these two have the same area. The length of the rectangle, so that's this piece, the length of the rectangle, is 5 inches more than, so something plus 5, twice the length of the side of the square. Okay, so we don't know anything about the length of the side of the square yet, so let's call that x. And it says twice that length, so 2x. So now that I've irresponsibly used x here, I'm going to have to label my other diagram with that information. So I just identified the length of the side of the square as x. So far I've gotten this part. The length of the rectangle is 5 inches more than twice the length of the side of the square. That's an awful lot of annotation. The width of the rectangle, okay, so we'll go back to our width. The width of the rectangle is 6 inches less than, so something minus 6, the side of the square. Okay, so there's no twice, there's just the side of the square. It says to find the length of the side of the square. So since that's the question, annotation, usually we circle that. Let's finish our annotation here. The width of the rectangle is 6 inches less than the side of the square. So here's our setup. And in order to solve this problem, we have to keep in mind that the square and the rectangle have the same area. So the area for the square is fairly straightforward. Area of square is equal to length times width. And in this case, the length and the width are the same thing. We know that this value has to be x as well, because it's a square. Area is equal to x times x, and of course that's the area is equal to x squared. So there's a little button here for squared. That's very annoying. And for a rectangle, it is also length times width. So the area is equal to length times width here. So now I can write down that my area is equal to length, which is 2x plus 5, times the width, which is x minus 6. And we're going to have to use our double distributive property to solve this. I know that 2x times x is equal to 2x squared. 2x times negative 6 is negative 12x. 5 times x is plus 5x. And 5 times negative 6 is negative 30. So we can simplify that. Instead of writing this whole mess out, we can say that the area is equal to, combining like terms, negative 12x plus 5x is negative 7x. Okay, so we found our two areas. It does tell us that the square and the rectangle have the same area. So what we're going to do is set those two areas equal to each other. A little space for moving around here. I'm going to use a different color so that people watching this video can keep track of what I'm doing. Use purple, my favorite color. I know that the square and the rectangle have the same area. So I know x squared is the area of the square. How appropriate of a name is x squared then? And that should be equal to this area, which is 2x squared minus 7x minus 30. Just throw that in there. Wrong color. Okay, so now they're equal to each other, but you know that a quadratic equation, we want it to say equals to 0. So the first thing we're going to do is subtract x squared from both sides. Minus x squared minus x squared. So on the left-hand side we have 0. On the right-hand side we have not 2x squared anymore. We got rid of one of those x squareds, so now all we have is x squared minus 7x minus 30. And once we have a quadratic equation that looks like this, we can use a number of different methods. We can use the quadratic formula, we can graph it, but my favorite way is trying to factor it using the A&M method. Since there's no number in front of the x squared, we can use the A&M method pretty easily. We're looking for two numbers that multiply to give us 30 and add to, negative 30, and add to give us negative 7. I believe that should be negative 10 and also positive 3. And we can check that. Negative 10 times positive 3 is negative 30. Negative 10 plus positive 3 is negative 7. I've been doing this a long time. Alright, we'll put the little line here, and we'll solve both sides of the equation separately. We know that this side is going to be 0 equals x minus 10, and the other side is going to be 0 equals x plus 3. On both sides we're going to solve for x, so here we'll add 10 to both sides, and we get 10 equals x. That seems to be pretty logical to me. On this side though, something odd is going to happen. We're going to subtract 3 from both sides, and we're going to get x is equal to negative 3. On this side, we're going to eliminate this answer. We can say underneath it, we can type the word rejected. We reject any negative answer in a real-world problem like this because we can't measure using negative units. So this one is a reject. So our correct and complete answer should be the square has length and width equal to 10. Alright, I hope this video was helpful. There were 3 different examples of quadratic word problems. Please send me an email if you want me to do another type of problem. Good luck studying.